Hello everyone, welcome to the garage. I'm Fast Rod, and as promised, in this video I will be covering the kind of breakdown of what um, real world engines are made of and components and stuff like that. I did promise that in the last video. I must also apologize for taking so long. I had this kind of already going a little bit, but due to the fact that the Fallout 76 season was ending and my current character in that requires the paint jobs that were available through the season. Um, kind of had to walk away from recording and editing and everything. I do apologize for that. I'll see about keeping that to a minimum um, going forward. But as I said before, we're covering the kind of breakdown of what engine components are, the names, the terminology. Um, Another thing, this will be unfortunately a two-part video. If you're hearing this video, hopefully the following part will already be up. I'll do my best to put both of them up at around the same time, just to kind of avoid any unnecessary wait times or anything like that. Um, so without further ado, let's get into it. And first off is materials. Materials, basically what the engines are actually made out of. There are various materials that go into an engine. Um, Iron, forged aluminum, aluminum, all these are terms and phrases kind of thrown around um, for various parts on these components. And like I just said, iron, cast iron, steel, forged steel, aluminum, billet aluminum, and even titanium. All these are metals and materials used in engine component parts. Starting with iron. Iron is pretty basic. You can find it naturally and stuff like that. Forged iron is, to my understanding, the component is poured into a mold. It's, as they say, casted, and then after that, um, for forged parts, what they do is they actually kind of squish the casting again to, kind of compress the metal and really make sure that the metal and the material that they've used for, that part, this also goes for steel, they kind of squish it to ensure that the part really has been stamped. And usually the way you can tell what is forged and what isn't is usually a small seam running through the part. On forged, components that have been, kind of squished a second time, they'll usually have a thicker line, a thicker cast line, kind of running down that particular cast line. Um, and then, of course, that also, if I'm not mistaken, also applies to aluminum. Now, billet aluminum is a bit different. I was actually trying to read up on that, on billet aluminum. Apparently, it was actually created quite some time ago. Um, but as far as automotive application and use, if I'm not mistaken, it's more of a recent thing, just due to the scarcity of aluminum. Way back in the early 1900s, you know, due to that, really the billet aluminum innovations and stuff like that, in terms of automotive use, have really been maybe only in the past 30 years or so. And the last metal obviously being titanium. Uh, like I said, believe it or not, titanium actually is used in stuff, in different parts that go on an automotive engine. Usually, it's more of racing team stuff. Think of NHRA, funny cars, dragsters, um, Formula One, NASCAR, really, really top, top level sport teams are what use titanium parts. Um, I do believe folks related to street outlaws, kind of in that side of things. I believe they also do use titanium parts. Um, like I said, it's pretty wild, but I mean, you need the strongest metal you can get, just because sometimes engines are exposed to really, really crazy conditions, and the strongest, the toughest metal you can get is what's going in. Um, Reason why they don't just use, iron or steel, parts all the time is because they're pretty heavy. And once again, it comes to a thing called power to weight. Um, it can have a lot of power, but if it's really heavy, all that power may barely move the thing. If it's really light, but it's not really that powerful, once again, it may barely move it. But if it has a lot of power and it's rather light, you know, you can go really fast. The end goal of using a lot of these different metals is to usually go as fast or have as much horsepower and be as light as possible. Um, with that said, the next thing would be engines. Engines are basically the power plant of most gasoline and diesel vehicles. I do have to correct that in terms of I'm not going to be talking about electric vehicles or hybrids or hydrogen or anything of that. I'm not going to be talking about those yet. Um, and I don't mean that in this video at all. I'm not going to be talking about them here in this video at all. I'll probably give them their own dedicated video, just because I need more information on that first off, and even then, I think it might be a very interesting topic, so I'd like to give that its own video. Um, so for the rest of this video, I will be referring to gasoline and diesel engines. Um, the Now for the actual individual components. The first individual component to talk about is the engine block. Engine blocks are basically the main structure that all the subsequent pieces that I will be talking about bolt onto or screw onto, or any various ways of attaching them. They All the other components I'll be talking about, they all attach to this main component called the engine block. The engine block houses the pistons, houses the rings, it houses the crankshaft. The heads bolt onto this, oil filters, um, oil lines, oil fittings, coolant fittings, water pump. All these parts bolt onto this one main component, the engine block. Having that said, next are the heads, or as they should be called, cylinder heads. Um, these cylinder heads create the rest of what is known as a combustion chamber. Combustion chamber is made up of three parts: the engine block that I just discussed, the cylinder heads that I'm talking about right now, and the part that I will be talking about in a bit, the pistons. Those three components make up a cylinder, a small little chamber where the controlled explosion of air and gasoline occurs. First it is compressed, then a spark plug sparks, creating an open arcing, similar to lightning, and therefore setting off a controlled explosion. So that is possible thanks to those three parts, and one of them is the cylinder heads. The cylinder heads not only not only are part of this, what is the chamber or the combustion chamber, but also they contain the valves. Valves, springs. Don't worry, I will I will be demonstrating them, and I'll be I'll give further explanation on those parts. But they contain those parts as well. Um, they also, for the most part, contain spark plugs as well, and obviously they go on top of and bolt on top of the engine block, and they're usually the about second part you'll, kind of when you're tearing an engine apart, they tend to be the second kind of layer of parts that you take off. And moving on from that, you have pistons and their rings. Um, these are very rather familiar terms, and more like uh, parts that people believe should be, and do typically talk about. Pistons are basically a cylindrical, um, sometimes flat topped component that goes inside of the block and attaches to the crankshaft, which once again I'll be, you know, talking about further, through a connecting rod. Um, the the piston um, doesn't seal, or doesn't it doesn't it has to fit within the hole on the engine block, because the engine block contains holes where the piston actually slides into, um, because the fit cannot be perfect, because otherwise it would take um, too much force to actually put it into that hole on the engine block. They use a thing called rings, or piston rings. Those are the part that kind of they basically expand, and they kind of fill the gap between the piston and the engine block cylinder walls, because once again it's basically a giant, it's basically a big old cylinder that it kind of slides into, and the piston slides into that. So what the rings do is they kind of fill that little gap so that it it's not too hard to push them in, but they can still kind of, allow the piston to travel up and down. Um, that is, the purpose of the piston rings. And when people describe piston rings as fried or broken, or it blew the rings, or the rings collapsed, when the rings collapse in that particular case, what they are talking about is that the piston rings have completely closed. They basically stop filling that gap, and they let the piston just move up and down, basically as if, you know, they weren't there to begin with. So it allows the piston to be, kind of be loose in there, and basically kind of slide up and down in that cylinder, as they call it, or that combustion chamber. It just moves up and down freely, no resistance, whatsoever. It can just, move up and down as it pleases, without really any real effort. Moving on from that, we have connecting rods and crankshaft, as I said earlier. Connecting rods and crankshaft. The connecting rods are basically a stick-like part that connects the piston and the crankshaft. Now, the crankshaft is the one part of the entire engine that's responsible for taking the up and down motion of the piston and turn that into circular motion, and basically twisting or turning motion and thus feed that into the transmission, which feeds it to the differential, which ultimately is, moved out to the tires and moves the car. The biggest piece that is responsible for that is the crankshaft. The crankshaft is, kind of the biggest piece to that puzzle. And without the crankshaft, all these other parts can do their thing, sort of, and unfortunately, they won't really matter. Um, the crankshaft really is kind of the biggest part of that, of this whole engine, both diesel and gas. It's perhaps one of the most important components of all, alongside, alongside the previously mentioned. Moving on from there, we have valves. Valves are basically like small little doors that let, depending on the engine as well, but for the most part, they let air and fuel in. Um, Once again, almost like a door. Think of it like a door. If you open a door, you know, wide enough, uh, 2, 3 people can kind of, you know, shuffle through that. If you open it a little bit, maybe a small kid can go through. If you open it for a long time, obviously as many people as they feel like going through that door can go through that door. If you only open it for maybe half, half a second, no one's gonna go through that door. Valves work the same way. They basically do the same thing, but once again, we're talking about air, and we're talking about, fuel or gasoline. That's kind of there. That's kind of the, the representation of, the people, walking through a door. That's kind of, the way that works. The way, you know, the way that is basically how valves work. That's kind of their job. They sit on the cylinder head. They are held back by, the next component, valve springs. Valve springs are basically responsible for keeping the door closed. And think of it as a door that, think of it as a restaurant door or a kitchen, door that you kind of have to push open. Those things have their own system to kind of keep it, closed. That's what the valve spring does. Valve spring normally keeps it closed. You have to push it, in a certain direction to open it. Then we have camshafts. Camshafts are basically the mechanical component that tells the valves when to open. They mechanically either push it open or they tell a very complex system, um, and long list and complex system of components when to open the valve. Like I said, the valve springs normally keep it closed. Well, the camshaft tells it when to open it and for how long to open it. That's basically what the camshaft does. Obviously, you can all see this, visually. Obviously you are seeing it visually. Um, and of course, one of the ways is through timing belts and chains. That is one of the ways that the camshaft tells the valves. That is also told by the crankshaft. Once again, a lot of these components tie into each other, and they usually will tie into each other through this. So, timing chain, timing belts, they are literal. Think of the chain on your bike, basically. The way that works, you have obviously the gear with the pedals on it where you kind of, push them up and down, or you kind of, rotate the pedals, and that is has a chain running all the way to the back tire, and then telling, obviously indicating the tire when to move and stuff like that. That's basically the most basic version of a timing chain or timing belt. Timing, there is a difference though between belt and chain. Obviously, a chain is kind of like what's on a bike, whereas a belt is actually made of rubber. It's a rubber version of the chain. Obviously, chains are made out of metal. You can have some chains made out of plastic, but they're, once again, not chains, they're belts. At least for automotive use, they are belts, and they wear out. Sometimes they break. So, when your mechanic tells you, hey, you got a broken timing chain, they're talking about that part that tells all of these other components, hey, when to work, when to open this valve, when to open that valve. Because there are more than one valve. I do apologize for not talking about that earlier, but there are more than one valve. There are some called intake and there are some called exhaust. The intake, kind of in the name, they allow stuff to go in. Exhaust, they kind of let stuff out. That's the breakdown on those. Do apologize for not talking about that sooner, but timing chains, they kind of help tie a lot of the previous parts together in terms of when to work. So the crankshaft, twists, well, say it twists one time around, the timing chain will take that, obviously the gears and stuff, it'll take that idea, or it'll take that, motion, and it'll take it to the camshaft and say, hey, kind of, it's kind of the messenger part of it all. So it'll relay that, it'll message that to the, camshaft, what the crankshaft is saying is going on. It'll basically tell it to the camshaft. The camshaft will then say, hey, open up this valve, open up that valve. And once again, that can happen through a timing chain, that can happen through a timing chain. Various, engines will obviously, have different setups. Old school hot rod engines, they only had a small chain and two gears. Modern engines, like say that on Mustangs, they have four cams, so four different, things. And each one is kind of specific. So it's going to be 2 and 2 on a V8. It'll be 2 on one side, 2 on the other, and basically 2 of them are meant for intake valves, and the other 2 are meant for exhaust valves. Obviously, you can see that on screen, but that is how that works. Now, when it gets a little more complex is when they do a thing called single overhead cam. Single overhead cams means there's only one cam on top of each side of the engine, assuming it has more than 4 cylinders. So more than one set of cylinders, more than one side to that. That's usually when it can get a little complex. But once again, all the timing chain is just kind of the messenger telling each part what's going on. Moving on from that, we've got fuel system or fuel delivery, which basically I'm talking about carburetors. Carburetors are the old ways of basically giving an engine fuel. So carburetors are the old way of giving an engine fuel. Basically, it would have a line running from the gas tank all the way to a thing called a fuel pump up at the motor, and then another line going from the a fuel pump at the motor, um, going to the carburetor. Once again, that's taking the fuel up to the carburetor. The carburetor basically would do two things. It would let air in, and it would also give it fuel. It would add fuel to it. So in gasoline, adds gasoline. Diesel, I know it works a little differently. This does not apply to diesel. Once again, I do know a bit on diesel, but I'm no expert by any means. Um, so I'm afraid that here's where I kind of have to cut off you diesel guys. I hate to kind of throw out diesel for the rest of this conversation, but kind of have to. I don't want to. I don't want to start, misinforming you about how diesel works. So, um, gasoline, gets kind of um, sprayed you know, into the intake, which is yet another part that sits usually in between the motor. There have been some experimental components that uh, sit in a very different position, but usually it's in V-shaped engines. Usually it's that center part. Um, Usually, because there have been some exceptions, but right now I'm not going to talk about those. So usually on old school hot rod, engines, it's the part that sits in between the V, and usually, that carries the air to, you know, through the cylinder head into the combustion chamber and, throughout the engine. Through, or not throughout the engine, but through the combustion chamber out to the exhaust and, so on and so forth. That has the carburetor on top. Like I said, the carburetor mixes the air and fuel right then and there. On later, with the advent of electronic fuel injection, which I'll talk about in a bit, um, it actually, as a matter of fact, why don't we talk about it? So, fuel injection. I'm sorry about that. So carburetors mixed it before the intake and let the air and fuel mix, on their way. Fuel injection does the kind of opposite of that. Instead of mixing it right then and there before it goes into the engine, fuel injection actually puts it in separately. So air can focus its way into the engine and fuel could just be added on its own and it could mix in the combustion chamber. Then from there, there are mechanical fuel systems. I do apologize. I meant to clarify that. There are mechanical fuel injection systems. Mechanical, well, it's kind of in the name. It doesn't use any electric parts. It doesn't use any kind of electronics. It's just purely mechanical parts. Purely mechanical parts run the system, and that's how it operates. It operates usually off a vacuum that's once again supplied by the engine. Another aspect that I, don't really have the time to cover, but that's another aspect of engines. So mechanical fuel injection, that is how that works. It literally has mechanical parts to work. Because, and I say that because in the late 1970s and the early 1980s, a thing called electronic fuel injection was kind of not invented, but perfected enough to put on day-to-day cars. And electronic fuel injection is a system that actually does use electronic parts and electronic components to inject the fuel, to spray the fuel in there. Most of those systems would be port injection. Now I do have to specify and clarify that by saying there are different ways to get fuel into the combustion chamber. That is what they're talking about. So, uh, multi-port fuel injection is something that came a little bit later after EFI because the early EFI systems worked similar to a carburetor. Um, of course, you also have tune port injection, which used a bit of a different system, but I'll get into that in a sec. The early EFI systems looked like a carburetor, but they were electronic. It was basically an electronic carburetor. Now, after that, obviously, uh, technicians and engineers in particular continued to kind of experiment and kind of create these new parts and kind of keep poking and prodding until they came up with sequential or multi-port fuel injection. Sequential means it's kind of like like I said, the early EFI system, but instead of being this carburetor like thing, it actually either had one or more injectors, electronic injectors, that would spray the fuel in, and they would either have, for example, in GM trucks, and I'm sure a lot of people who have or have had older Tahoes and Suburbans and Blazers, you know about this, the spider injection. It basically was this block that would take the fuel, and it had a bunch of small skinny hoses coming off it, and those would be the ones responsible for spraying it into the intake, and from there obviously it would go into the combustion chamber. There are many different ways that it happened, but engineers devised multi-port fuel injection or sequential fuel port injection. It has many different names, but the point is that it's either one or more electronic injectors injecting the fuel into either the intake, that piece that I mentioned before, so it's usually on top of or the valley or the V part of the engine, or another thing that came later was direct injection, meaning instead of putting it on the intake, they would just put it directly on the cylinder head and let it spray the fuel directly into the combustion chamber. That is what we call direct injection. So to recap this whole section, you have carburetors, which we started out with. Then we went to electronic fuel injection, or EFI, which was an electronic carburetor, I'm sorry, electronic carburetor. From there, we went to sequential or multi-port fuel injection, either multiple injectors or a cluster of them, distributing all the gas to all the cylinders. And then the current day is going to be the direct fuel injection. It sprays it directly into the, combustion chamber. And that is that part of it all. Then moving on, we have distributors. Distributors were the part that would send the spark or send the electric, current to a spark plug. They were a thing all the way up into uh, the early 2000s or so. The early 2000s, with Toyotas, Hondas, some Hondas still having them, even into the early 2000s. What a distributor was, and what it technically still is, because they are technically still around due to older vehicles, but they were a mechanical component that would once again read off of the uh, camshaft and would basically say, hey, where are you at? In the spinning cycle, where are you at? And you would usually be able to adjust them, basically kind of control. The camshaft has some teeth on one end, and then it takes 3 bolts, usually 3 or 2 bolts on the other end. Um, the 3 bolts, 2 bolts side is usually what goes to the timing chain and all that kind of stuff. On the other side, I don't have a gear. That side usually is the side that would take the distributor. The distributor would have its own gear, and basically those two gears would, obviously mesh, and they would kind of just spin off of one another. Well, that would go to a shaft going up into the distributor, which back in the old days they had uh, a couple of electric components in there, um, and a small little tab that would basically um, open and close 2 little touching points that ironically are called points. It would open in those, think of them as a little tiny door there. They would open and close, and you would have the electricity running through that. And every time they opened, obviously it would get cut off. Every time they would touch, obviously the electricity could flow again. And from there it would go, you know, throughout all the little different electronic parts in there, and then eventually go to the center, go through the, then go up to the cap and rotor. Basically, go through the rotor, go up to the cap, and the cap would distribute that electricity to the wires that would eventually go to spark plugs. Um, Unfortunately, in the early 2000s and even in the late 90s, they slowly began to phase that kind of technology out. Mostly because with so many parts, they can kind of, fail. Basically, um, you could have failing components. They really are, stuff that was developed in the 1920s, 1930s. So really old technology. Of course, slowly things have been changed in it, so they didn't just stay the same, but um, they did kind of change with the times and with as technology advanced. But it's really with the advent of newer engine technologies, why keep that kind of stuff around? They would eventually find ways to kind of get rid of that. Most famously, the LS motors found in Corvettes, Firebirds, Camaros, um, and Chevy trucks or GMC trucks. They kind of slowly got rid of that and went to a thing called coil packs. A coil pack is basically kind of the same thing, but it's all been kind of condensed down to a cluster. It's really just this giant pack, of coils that take the same thing, minus a lot of the electronics. Mind you, that a lot of the electronics that kind of help, the opening, closing, and the timing and all that kind of stuff. When to fire that electricity out to the spark plug. That kind of stuff actually was eventually removed altogether and moved over to the computer, to the PCM, BCM, um, to the basically powertrain control module, or basically, yeah, or electronic control unit. I've also heard it called. So they moved all that over to that side, so the computer could tell the rest of the parts, hey, when to fire, when to do this, when to do that. Um, that's what that is about. Like I said, coil packs, and then eventually they went to coil on plug. meaning the coil sits on top of the valve cover. It's a cover that goes on top of the cylinder head and keeps, a lot of the parts covered. That's why it's called a valve cover. Um, it sits on top of that, and it sometimes has a wire just going down to the spark plug. For example, on LS engines, once again, Chevy Camaros, Firebirds, Corvettes, Chevy trucks, they'll have just the small wire. Or if you're in Ford land, they have this, plastic or rubber tube just going all the way out. Once again, it inside it has a small spring and it connects the coil to the spark plug. Like I said, different manufacturers have done it different ways. But, it's basically the same technology. It's the same thing as the coil pack, except for coil packs usually used wires to get all the way to the spark plug, versus the coil on plug. It just uses a spring and a rubber or plastic sleeve, you know, to reach all the way to the spark plug. You know, they're basically the same technology. From there, we have mechanical limiters. A lot of people ask themselves, why can I only reach a certain speed? These days with modern cars, usually that's because the computer is only programmed to go up to X point and stop. Basically, you can't go past X point, be it 100 miles an hour, 93 miles an hour, whatever. If the engine is working this hard and and the tires are spinning this fast, we're not going to let you go past that. Back in the old days, there used to be mechanical or governors, as they were sometimes called, stuff like that. They were mechanical. They mechanically would stop the engine or the car from going a certain speed, or the engine from revving, you know, so far, stuff like that, so much or this or that. They mechanically stopped it. Like I said, these days they're not mechanically limited, they're usually electronically limited, meaning they've programmed the computer to only reach a certain point and stop. You can reach that point, you can stay at that point for a little bit sometimes, and then once you try going past that, or once the engine starts working harder than that, it'll actually start to you'll actually see it start to, kind of decrease, or, you know, if you have, an a RPM gauge, or revolutions per minute gauge, with the 1, 2, 3, you'll see it kind of slowly dip, kind of go back. You'll see it going from 5, 6, or 4 down. You'll see it go down to 2, 3, kind of see that. And the last thing to cover are chemicals. Chemicals meaning coolant, batteries, or not batteries because they don't fall under that, but coolant. What is coolant? Coolant, the chemical name for coolant is actually ethylene glycol. That's basically the green stuff. Technically, ethylene glycol is everything. If it's red, blue, green, purple, yellow, orange, red. I think I might have already said that. But anyways, they're technically all ethylene glycol, but there's some sort of mix of ethylene glycol and, water and, color and stuff like that. But yes, there's that. There's also, chemicals for gasoline. Basically, what used to be known as lead. If you've ever wondered why it says unleaded fuel, that's because prior to the 1990s, 1980s, you could get gasoline that had lead in it, a version of lead. in it, a liquid version of lead. Well, after several years of research, they found out, hey, that lead stuff in the gasoline, that's actually bad for human health. We should probably take that out. So the government decided to take it out. They said, hey, take it out. Take it out or else. And so gasoline makers took it out. That's why it has continued to say unleaded fuel, because again, it has to be gasoline that doesn't contain lead. And that's very important because if you get gasoline that does have lead in it, you're going to hurt some things. You're going to break some things. There's going to be, unintended consequences. The reason why, as far as I recall, why lead was added to gasoline was because, one, they did not have the technology we do. Two, not only did they not have the technology we do, but a gentleman was messing around with gasoline trying to make it burn better, and he found out that this chemical that uses lead, or a version of lead, a liquid chemical version of lead, burned really easily. Or it burned very controllably, I should say. And he said, hey, wow, this stuff is great. We should start using this. And he obviously got his technology out, and a lot of the gasoline makers said, yeah, that's really good. Let's go ahead and do that. And thus, there was leaded gasoline. Which, like I said, went away because, well, they found out, hey, that stuff, not so good. And sorry to have taken up so much time, but this turned out to be a much larger video than expected. With that said, I hope a lot of the visual aspects have helped. Just because it's a lot to take in. This kind of information usually takes several years. I won't blame anyone if you have to watch this video several times just to fully digest and fully understand everything I'm saying. And I may have not done any of these things, particular justice in explanation. Might have not been able to explain them particularly well. I do apologize if that is the case. I'm sorry if you do have to watch this a couple of times to really understand everything I've said. But this is, that's what this video is intended for. It's intended so people could kind of reference this. And if you're, wanting to get into automotive, or if you want to at least understand the way engines work, hopefully I've done this justice in explaining how they work, and definitely giving you, some knowledge here. Hopefully I've dropped some knowledge around here to really help you, explore all these kinds of things. And this doesn't limit itself to just car engines. Some of this information can also be applied to two-cycle. Motorcycle, basically, what I'm talking about are motorcycle engines and lawnmower engines. Some of this stuff does apply. Some of these ideas and the things that I've talked about in this video, they apply. Not everything, but it never hurts. One of the things that I'd like to kind of get out of the way here is that I've been told and I've been taught that an engine needs 4 things to work. It needs gas, it needs air, it needs to squish that or compress, compression. It needs to have that. It needs to be able to squeeze these things, and it needs to obviously have spark, meaning it needs to burn that. If the spark plug doesn't work, guess what? Nothing's gonna happen. If no gasoline is going inside, it's only air and the fire part, it's not gonna work. Recently, some personal things have reminded me that, hey, these engines in general need to be able to squish the air and gas. If it doesn't do that, it's not going to work and it's going to be a whole heap of trouble. Um, with all this said, thank you all for listening. I hope I have informed you a little bit. Um, and be on the lookout for the second part. It should either be out very soon. If not, it should be uploaded at around the same time. Um, thank you all for listening. Thank you for hearing me blab on for about 50 minutes, basically almost an hour. Hopefully, if you already know some stuff, hopefully just leave it in the comments if you already know some of these things. If you learned something new, also drop it in the comments. I very much thank anyone who's willing to comment. Um, especially if you have something to add, go ahead, drop it in the comments. I can't say that enough. We're all here. We're all here to learn, including myself. I may know a lot, but I don't know everything. So, with that, see everyone in the next video.